All right, let's look at example 3. And you are now looking at, using the concept of operations of functions to measure the relationship between the mass, which is the weight of an animal, and that is rhinos, and the heartbeats in a lifetime. Okay, sounds big and many. Here we go. You have a function r of m, which is right now we're looking at the rate of the heartbeat of a rhinos, okay, due to its mass, which is its weight. You have 241, and the mass here is m to the negative 0.25. Okay, read the example, example 3. You will see that, okay, Mr. Dan, here we have. All right, and then the next one right now is the heartbeat and their lifespan in minutes, which is S right here. Okay, depends on their size, 6. Okay, all right, this is 10 to the 6 MO2. Okay, the rate of their heartbeat, and this is right here. You will see S right now is their lifespan, their lifetime. So when you time together, you will get the total number of the heartbeats for their lifetime. Isn't that cool? So let's do, when you multiply the two functions together, that's it. That's what you are being equipped right here, and figure out in the lifetime of a rhinos, due to their mass, see how many heartbeats you will find. Here we go. Let's conduct that. Technically, take R, okay, M times with S, M. There we go. By doing this timing together, you will have the total. You have the total number of the heartbeats of a rhinos in its lifetime. Kind of call it it. Okay, here we go. 241 M negative 0.25. Okay, 0.25. Okay, I hope you see that. That time with this right here, 6 times 10 to the 6. And M right here, what? 0.2. Now, ladies and gentlemen, we are dealing with multiplication. Okay, I am just simply multiply the constant together, and I just time the variable together. The variable right now, it is in same base. If it's in the same base, I keep the base at the exponent. So what's the outcome right here? 241 times with 6, 10 to the 6, what you have? Well, to keep all in significant figure, let's put this way for you, okay? All right, here we go. 6 times that right there. How about I take 6 times 241? Look, what is 6 times 241? That's right. I got right here is 1, 4, 6, and 6, 10 to the 6. There we go. That's taking care of the first thing, constant. Now, M negative 0.25 times with that. There we go. Negative 0.25 add with 0.2. There we go. You see it? Okay, so now what do I have here? Time this together, you will see that 1, 4, 4, 6 times with what? 10 to the 6. And this is M. There we go. You can see that a negative 0.05. This is 0.05. Okay. Now, ladies and gentlemen, this is written in the form of scientific notation. Okay. All right. Now, we will have the interpretation, and they ask us, what does that mean? It means that this due to the mass of a specific rhinos. You can bring the mass in, put them on the scale, big, huge scale, plug it in, you will see what? Time them all out, you will see the total heartbeats of a white rhino, it's a rhino, over its entire life. Isn't that cool? Okay, shall we move to the next concept? And that is the last part, and composition. All right, guys, this is new word for you, okay? Composition. We're coming to the composite function, okay? Can I erase the board? Okay, look with me on the key concept of of composition of functions. What does that mean? Look at the picture and you will see that, okay, Mr. Deng, I see 4 circles, not really circles, but more likely ellipse right here. And what does that mean right here, Mr. Deng? You have what? You have a h of x, and that equals g of f of x. There we go. That's how you say that. Mr. Deng, what does that mean? Composite function. How do I understand? Can I give you a very practical application, and hopefully you will capture right away? First, let's give you the verbal explanation. Look, whatever the function of f of x, you will now, look right here, if you are given right now 2 functions, g of x equals something, f of x equals something, whatever the variable of g, just substitute by f of x. What do I mean by that? Here is my preparation for you. Let's say student A, okay, he runs with the speed limit of x mile per hour. X mile per hour. Okay, let's say student A. I wish I can call your name, but you know, we got 28 students in here, so you might feel a sense of left out. A student A runs with x mile per hour. Student B, let's say, sorry, reverse. A student A walking with x mile per hour. I don't know how many miles per hour, but I just call it x mile per hour. Okay? Now, student B, this guy or this gal runs. This student B runs twice the speed of student A. Here we go. Student A, this is student A, f of A. Okay, this is f of A. And this is g of, function f from g. Okay, this is student B. This is student B. Okay, student B runs twice the speed of student A. Can anyone tell me what is twice the speed of student A? What is student A? X. Right there. You see? Now you're coming into what is now the composition of functions. Student A walks x mile per hour. Student B runs with the speed twice the speed of student A. How about student C? There we go, student C. And that is, let's say, student C, okay? Function K, okay? Student C, function K. Student C rides his or her bike. Student C rides her bike with the speed of 3 times of student, this is running. 3 times the speed of student B. How do you write the function for student C? Student C rides a bike, and the speed of the bicycle running, the bicycle riding is 3 times the speed of student B running. So is it 3 times x? Oh no, big no, Mr. Dan, because the speed of student C is 3 times the running guy. So there has to be what? You got me. Where to go? Where to go? Has to be what? 2x right there. Do you see it? There we go. That's 2x right there. The concept right now, you will see, oh, Mr. Deng, I see. Look, student A, this is f of x equals x. Got it? Student B. Let's say g of right now is what? G of f of x, which is what? 2 times, what is f of x? X, right there. You got it? Now, what about student C? Student C, K right now is what? K of what? K of G of x. There we go. Now, we know that student C, 3 times G of x. What is G of x? Oh, there we go. So this guy is what? Technically 6x, which is 6 times the walking guy. Ladies and gentlemen, the concept of this right here is called composition of functions, composite functions. There we go. I hope this makes perfect sense for you. Okay, shall we really now get into the example? Let's do example 5 with me. What time is this right now? Okay, let's do. All right, let's do example 5. Okay, here we go. Example 5. Example 5 you have right here with me is, okay, here you have f of x equals 4x negative 1, okay, and you have now g of x equals 5x minus 2. All right, the problem asks us to conduct what is A? Composite f of g of x. There we go. All right, you guys ready? You guys ready? Okay, here we go. Okay, here we go. Look at this. This f, what is f? F for x negative 1, Mr. Dang, x negative 1. Can I rewrite this guy for you? 1 over x, okay? And the 4 stand of what? 4 times 1, which is what? 4. That's it, technically. But look, y'all look, Mr. Dang, your variable of f right now is the whole function g of x. Remember we just did the running guy, the walking guy, and the bicycle guy? Look, f of g of x. So whatever the variable of f right now is being substituted by the whole g of x right there. So this is x, f of the variable here is x, but you will not put x. What did you put? You put the whole function of g right there because that's the concept of composite function. This is composite function. So instead of writing x, what is your x here, guys? That is the whole g of x, which is right now, you will have what? 5x minus 2. There we go. Okay? All right? Okay, that's right now. That's what we're going to have right there, ladies and gentlemen. Okay, I'll just do it again for you. Mr. Deng, what if I keep it same thing like this? What shall I do? Look, let me do another way for you, okay? F of g of x, same thing. Look, 4x negative 1. But your x right now is being substituted because you are asked to do f of g of x, okay? This is the new variable for f right now. Got it? So it is a function, so plug it in. 5, let me put this column for you. 5x minus 2. To the what? To negative 1. These are both equivalent, just so you know. By doing this, it is very clearly, very helpful to see and to help you that the denominator cannot be negative, which means what? 5x minus 2 cannot be 0, meaning x cannot be what? 2 over 5. There we go. That will help you to determine that this function, the composite f of g of x right here, it makes sense for all value of x except at the point x equals 2 over 5. Because at the point x equals 2 over 5, the function is destroyed. Why? You have a 0 in denominator. So I think that makes very perfect sense for you, right? Now let's look at another part, which is part B. Okay, let's look at part B, shall we? Okay, here we go, part B. All right, you have part B right here. G, now you go the other way. G of f of x. Ladies and gentlemen, now look at this. The new variable for g right now is no longer x, but whatever x of g now being substituted or being replaced by the whole function of f. Make sense? So, shall we? Let's go. What's your g? Your g is right here, okay? your g is right here, which is 5. You see it? Now, instead of x, what did you do? Instead of x, you will put in the whole function for f of x, which is what? 4x negative 1. There we go. And now, simply close that because 5 times x. Okay, 5 times x. Let me use different colors so you can see. Okay, there we go. 5 right here. 4x negative 1. There we go. And that's it. That's just f of x right there. Now, the 2 right here, minus 2, go into another itself right there. Okay, because minus 2 right there. So that is your your g of f of x. Can I complete this and simplify that? What is 5 times 4? 20. Okay, 20. X to the negative 1 is simply what? Over x, just to give you a clear picture. Okay, and then minus what? Minus 2. There we go. Now, by looking at this function right here, and you say that, Mr. Deng, I see that in this composite function right here, all values for x make sense except x cannot be what? That's right, x cannot be 0. Okay, so you see the domain of the composite function of g of f of x right now is all values for x except x cannot be 0. Okay, and that makes sense right for you right there. That's the domain. X can be all real numbers except it cannot be 0. Okay, what about C? We're almost there. Okay, C now you have, what if a composite of itself, Mr. Dan? Well, even better. There we go. Same procedure, same process right here. Okay, what do you have here, guys? Okay, here we go. What do you have? F right here, 4. And can I put this word for you? Just 1 over x. Just there we go. However, your x right now is no longer x, but it's what? It is the whole function of f of x itself. So therefore, what do you put now? Look, okay, the whole function right now, since x negative 1, how about we do it just, like that for you? Here you go. Whatever for f of x right now, plug it in for that, which is what? Another 4x negative 1. And don't forget this one, the whole thing to the negative 1. There we go. Okay, you got it? Now we have to be careful with this. Look at this right here. Look right now, one step at a time. Ladies and gentlemen, do not time 4 to 4 because the whole thing right now has a negative 1. So one step at a time, okay? Make this positive first. So this is, you have 4, okay? And then 1 over what? That's right. 4 what? X negative 1. There we go. Beautiful, right? Now, ladies and gentlemen, you can what? You can do that right there. Okay? You can do that right there. Okay? So, by doing that right now, what do we have right here? Which is, oh, Mr. Deng, so just this simply I have what? 1 over x minus 1. But then I have a negative, a 1 in exponent of denominator. I want to keep positive. What shall I do? Well, that is just simply x itself. There we go. That is just simply x itself. Therefore, it can be what? All real values right here. However, all real value right here. But you have to go back to the original function. Mr. Deng, what is the domain for this guy, Mr. Deng? The domain, even though now you got a simplified in the simplest form, but you have to be careful with where you come from, the original guy right here, which means you cannot have 0. You cannot have 0 in denominator. Therefore, all real values except at the point x equals 1. Except because this one right here, original composite function, it has 0 in denominator. It's a dead end right there. Okay, so I believe I make myself perfect sense for you right there. All right, let's go to the next example, shall we?